class students. Now I am going to present you the video on synthetic fibers. This video covers the entire chapter explanation. Okay, so before I start explaining you the reflection of concepts and application of concepts and higher order thinking questions of the workbook, do watch this video and if possible try to keep this video forever with you till you are in the 8th standard. Okay, this covers the entire explanation, and the activities which I am going to tell you are the textual activities. We will be covering each and every corner of the textbook in this digital video which I am going to give you.
Welcome to the chapter Synthetic Fibers and Plastics.
This slide presents the overview of the chapter. Learning objectives. By the end of this chapter, you will be able to
Define synthetic fibers. Explain the formation of synthetic fibers like nylon, rayon, acrylic, and polyester. List out the properties and uses of synthetic fibers like nylon, rayon, acrylic, and polyester. Identify the different fibers by burning test. Define blending. Compare the synthetic and natural fibers. Define what is plastic. Explain the types of plastics and their uses. Differentiate between the thermosetting plastic and thermoplastic. Compare biodegradable and non-biodegradable materials. Discuss the effects of plastic on environment. Discuss the 4R principle. Explain the role of codes in the recycling process.
Introduction. Before entering into the chapter, follow the instructions shown on the screen. Click each tab to know more.
We know in lower classes we have studied that the clothes which we wear are made of fabrics. These fabrics are made from fibers obtained from natural or artificial sources. Can you answer the following questions? Are all variety fabrics in our daily life made of natural fibers? Can you name some natural fibers? Let us find out the answers to such questions in this chapter. Introduction to fibers. We have already studied that a fiber is a thread which can be spun into strings, rope, and cloths. A fiber can be obtained naturally or artificially. Note: fabric is a cloth material made by weaving or knitting threads together. The fibers which we obtain from nature, that is from animals and plants, are called natural fibers. All natural fibers are used for making fabrics, which are further used to making clothes, or the most important need for human beings. Natural fibers also protect human beings from extreme temperature and climate change. Furthermore, these fibers are used for making ropes, fishing nets, carpets, sails, and a variety of other articles of daily life. However, the demand for fibers and fabrics increases in such a way that the natural fibers are not sufficient to fulfill the demand. To overcome this problem, scientists have developed artificial fibers using petroleum products and coal as raw materials. These artificial fibers are commonly called synthetic fibers or man-made fibers. Let us perform a simple activity to understand the synthetic fibers in detail. Take a few paper clips. Join them together and observe the pattern of paper clips. Similarly, take a few beads. Join them together with the help of thread and needle to make a necklace. Now, observe the pattern of beads in the necklace. In both cases, they form a long chain from simple things such as bead or a paper clip. Here, each bead or paper clip is a separate unit, but when many such units are joined together, they form a new different structure. Similarly, synthetic fibers have a chain-like structure formed by joining small units together. Each small unit in the chain is known as monomer. The word monomer comes from two Greek words, mono and mer, which means one and unit respectively. So, a monomer is a simple unit of a given chemical molecule. Many such identical simple units are monomers combined to form a large unit called polymer. The word polymer comes from two Greek words, poly and mer, which means many and pot or unit respectively. So, a polymer is made of many repeating units. Hence, we can say that the synthetic fibers are made of very large units called polymers. Unlike natural fibers, synthetic fibers are made from petroleum-based chemicals or petrochemicals. Petrochemicals are subjected to various chemical processes to obtain synthetic fibers. These petrochemicals are the source material for many polymers and synthetic fibers. Types of synthetic fibers. Depending upon the types of chemicals used for manufacturing, synthetic fibers are named as nylon, rayon, acrylic, and polyester. These fibers cannot be identified by simple visual inspection alone in the absence of a brand label. But we can identify these fibers with a fiber burning test. Here, we can perform a simple activity to identify the synthetic fibers. Take a piece of cloth. Pull out a thread. Hold the thread with the help of tweezers. Now, burn the thread on the edge of a flame. Suppose the thread catches fire easily and burns with a bright yellow flame. Then it is said to be cotton or rayon. Similarly, if the thread does not catch fire easily and smells like burning hair, then the fiber is said to be silk or wool. Likewise, if the thread melts in the flame, then it is said to be a synthetic fiber such as nylon and acrylic. In the same way, if the thread shrinks in the flame and forms a black-colored bead that cannot be crushed, it is a synthetic fiber such as polyester. Now, we are going to study about nylon, which is a type of synthetic fiber. Nylon was the first commercially synthesized fiber. The production of nylon was started simultaneously in New York and London. Thus, it got its name, NY for New York and LON for London, as nylon. In 1931, it was made without using any natural raw material from plants or animals. There are various nylons such as nylon 6, nylon 6,6 and nylon 510. Let us now discuss how nylon is prepared. Nylon is the first processed synthetic fiber made of coal, water and air. It was more popular during the Second World War days. The nylon fiber is a polymer made of chemical units called polyamides. The polyamide is a chemical unit made of two monomers called hexamethylene diamine and adipic acid. Solid chips of these polyamides are melted and forced through a heated spinneret which has very tiny holes. The size and shape of the holes change the characteristics of the resulting fiber. The fiber solidifies as it cools and can be spun or woven. Nylon fiber is strong, elastic, light in weight, so it is popular for making cloths. Now, let us discuss the properties of nylon. It is a strong and elastic material, hence suitable for tracksuits, combat uniforms and parachutes. It dries quickly and absorbs very little water, hence suitable for making swimwear. It has high strength. Owing to this reason, it is used to make climbing ropes. It is durable and a lightweight material and therefore is used for making small machine parts and fishing. It is not attacked by moths and moulds. It has a static electricity property. That is why we can hear a cracking sound when the nylon clothes are worn. Uses of nylon. Nylon is a very strong fiber. That is why it is used for making parachutes, rock climbing ropes, fishing nets, tire cords, car seat belts, toothbrush bristles, etc. It is used in the production of textiles like saris, shirts, neckties, socks, and other garments. It is also used in the making of swimsuits, sheer hosiery, sails, umbrella cloth, car seats, sleeping bags, etc. Nowadays, it is also used as an alternative in the place of wool in the making of carpets. Nylon catches fire very easily. For this reason, we should not wear these clothes while cooking, lighting crackers, wedding, welding works, working near a fire, or using heavy machineries. Here, let us perform an activity for finding the strength of nylon. Click each tab to know more. Take an iron stand with a clamp and place it on the table. Now take 4 threads of different fibers such as cotton, wool, nylon and silk. Make sure that all threads should be of the same length and of almost equal thickness. Tie one end of a cotton thread with a clamp of iron stand in such a way that the cotton thread hangs freely from the clamp. Now, attach a weight hanger to the free end of the cotton thread. Leave the hanger, the thread gets suspended in a vertical position. Add small weights to the hanger and observe the thread. Keep increasing the weight of the weight hanger until the threads break. Repeat the same process with nylon, silk and wool threads. We have observed that the total weight required to break the thread was maximum in nylon, followed by silk, wool and cotton. Finally, we will learn that nylon thread has the maximum tensile strength, followed by silk, wool and cotton. We also learn that the fiber that breaks at the maximum weight has the maximum tensile strength. Now, let us study about rayon, which is another type of synthetic fibers. We know about natural silk, which is obtained from silkworms and that was discovered in China. The discovery of silk was kept a closely guarded secret for a long time. For this reason, the fabrics made from silk were very expensive. But the beautiful texture of silk has fascinated everybody, but the production and maintenance of silk is very difficult. To overcome these problems, scientists attempted to make artificial silk and they were successful in obtaining a fiber having properties similar to that of silk by the end of the 19th century. The first commercial production of artificial silk was achieved in USA in 1911, but this fiber was named rayon only in 1924. The first rayon factory in India was established in Kerala in 1946. Here, the raw material for the production of rayon is pure cotton or wood pulp. It is the only synthetic fiber obtained from a plant's cellulose and so it is called cellulose fiber. Sometimes it is also regenerated fiber because it is produced by modifying natural fiber. Let us now discuss how rayon is prepared. In the process of rayon preparation, the cellulose is collected from wood or bamboo pulp. Initially, cellulose is dissolved in the concentrated sodium hydroxide solution, and then carbon disulfide is added to that solution. Cellulose dissolves completely in chemicals added to it and gives a yellow-colored syrup-like liquid called viscose. Viscose is forced through the fine holes of the spinneret, metal plates with very tiny holes, into a solution of dilute sulfuric acid H2SO4. As a result, silk-like threads are formed. The formed threads are cleaned with soap and dried. The new fiber is called rayon, which is an artificial silk. Some kinds of rayons are made from a short cotton fibers left on cotton seeds after zinning. Rayon is cheaper than silk and can be woven like silk fiber. It can also be dyed in a wide variety of colors. But it is not the perfect fiber to prepare all fabrics, because it is made from plant cellulose. Let us discuss about the properties of rayon. Rayon is highly absorbent and is therefore used to make gauges for covering wounds. It is soft, comfortable and absorbent like cotton and has the shine of silk. These properties make it a good fabric for clothing. It drapes like silk and is much cheaper, hence a good fashion fabric at a much lesser cost. It is a strong fiber and therefore is used to make automobile tire cords. It burns at high temperature and does not melt easily. It absorbs water easily, which makes rayon weak and causes the fiber to break. We will now discuss the uses of rayon. Rayon can be mixed with cotton or wool, which makes it more suitable for our needs. On mixing it with cotton, it is used to make a good dress material, aprons, bed sheets and caps. On mixing it with wool, it serves as a good fiber for making carpets. Rayon is also found in sanitary products, diapers and bandages and lints for dressing wounds. Now, let us study about the acrylic, which is another type of synthetic fiber. Generally, we wear sweaters and use shawls or blankets in winter. Many of these are actually not made from natural wool, though they appear to resemble wool. These are prepared from another type of synthetic fiber called acrylic, and it became commercially available in 1941. Acrylic fiber looks like a natural wool, but it is an artificial wool. It is generally known as fake fur. Let us now discuss how acrylic is prepared. Acrylic is also another processed synthetic fiber made up of coal, water, air, oil and limestone. Acrylic fiber is obtained by the polymerization of acrylonitrile monomer. These polymers can be spun by either a dry or a wet spinning system. In dry spinning system, the polymers are dissolved in a suitable solvent such as dimethyl formamide, extruded into warm air, and the fibers are solidified by evaporation of the solvent. In the wet spinning system, the polymer is dissolved in a solvent, extruded into bath and then dried out. The acrylic fiber made from artificial sources is less expensive, whereas clothes made from natural resources are expensive. So, the cloths made from this fiber are relatively cheap and are available in a variety of colors. It closely resembles wool in its properties. Some of the well-known acrylic fibers are Orolon, Acrylon and Cashmelon. Now, we discuss about the properties of acrylic. They are washable and shrink-proof. They are quite resistant to the action of chemicals and also resistant to the attack of moths and other insects. We will now discuss the uses of acrylic. These fibers are used for making fleece, socks, sportswear, sweaters, shawls, and blankets. These are also used in craft yarns, upholstery fabric, carpets, luggage awnings, and vehicle covers. Now, let us study about the polyester, which is another type of synthetic fiber. The polyester is another synthetic fiber which is made up of the repeating units of polymers of esters. Esters are the chemicals which give fruits their smell. Terylene, Dacron, and terene are the examples of polyester fibers. Terylene can be drawn into very fine fabric fibers and that can be woven like any other fibers. Terylene is often mixed with cotton to make terrycot and with wool to give terry wool. Let us now discuss how polyester is prepared. Polyester is produced by reacting terephthalic acid with dimethyl ether and then with dihydric alcohol. The fibers are melted and spun by a process very similar to the one which is used to make nylon. This property allows the fiber to be converted into different shapes and sizes. The polyester fibers are hot drawn to improve strength, stress, and strain properties. Since polyester is melt spun, it retains the shape of the spinneret hole. This property allows the fiber to be converted into different shapes and sizes. Polyester fibers of these days are ultra-thin microfibers, which give them a smoother, softer feel than the polyester of 20 years ago. Fabrics are sold in the market by names like polycot, polywool, terrycot, etc. As the name suggests, these are made by mixing of two types of fibers. Polycot is a mixture of polyester and cotton. Polywool is a mixture of polyester and wool. PET, polyethylene tetraphthalate, is a very familiar form of polyester. Now, we discuss about the properties of polyester. It is strong and wrinkle resistant. It is lightweight, unaffected by water and resistant to sea salts. So, it is used to make sails of ships. It is resistant to stretching and shrinking, hence good for making curtains and draperies. It absorbs very little water, so clothes dry out quickly. It is not so elastic and is therefore unsuitable for stockings. It is quite resistant to the action of chemicals. We will now discuss the uses of polyester. The base material of polyester can be used to make not just fibers for fabric, but many other things like for making fabrics for suits, jackets, shirts, trousers, saris and other dress materials. It is also used for making sails. PET, polyethylene terephthalate, is used for making bottles, utensils, films, wires, and many other useful things. The PET bottles can be identified with resin identification code, which is present at the bottom of the bottle in a triangle-shaped symbol with a number in its center. We will observe that many bottles will have 1 in the center of the triangle. Then such bottles are said to be PET bottles. We will learn about resin identification codes in detail in the later part of this chapter. Let us study about the mixing of fibers. The process of combining different fibers into a single fabric is called blending. This process is made to improve the quality of blended fabric and provide the desired characteristics. But long fibers cannot be used in that process, so they are being cut into smaller staple fibers, and only after that they are blended into fabric. When a fiber is combined with other fibers, certain qualities of the first fiber are combined with the qualities of the other fibers, and they give us a blended fabric which possesses the best qualities of both. Blending helps us to reduce the limitations of both fibers. For example, polyester is the most blended manufactured fiber. Polyester fiber is strong, resists shrinkage, stretching and wrinkles, is abrasion resistant, and is easily washable. Blends of 50% to 65% polyester with cotton provide a minimum care fabric used in a variety of shirts, slacks, dresses, blouses, sportswear, and many home fashion items. A 50% polyester and 50% acrylic blend is used for slacks, sportswear, and dresses. Blends of polyester 45% to 55% and worsted wool create a fabric which retains the beautiful drape and feel of 100% wool, while the polyester adds durability and resistance to wrinkle. The greater the percentage of natural fiber in blending of fibers, the higher would be the comfort to the skin. When natural fibers contribute to a fabric, it allows the skin to breathe easily. Also, natural fibers are generally free from irritating chemicals. Why synthetic fibers? We know that synthetic fiber is a chain of small units joined together in which each unit is actually a chemical substance that is produced synthetically or artificially, usually from petroleum products. Synthetic fibers have unique characteristics due to which they have become popular. They dry up quickly. They are durable, less expensive, easy to maintain, readily available, easy to wash, and are easy for maintenance. They do not allow air to pass freely through them, and hence they are good and more comfortable in winter, but not comfortable in summer because they do not absorb sweat quickly. The main disadvantage of synthetic fibers is that if they get burnt, they melt and stick to the body of the person wearing it. So, we shouldn't wear clothes made of synthetic fibers while working in the kitchen or in a laboratory. Washing and ironing are also different for synthetic clothes. For example, we can see some labels called laundry label codes on the collars of shirts or inside the frocks and trousers. Based on the laundry label codes, customers determine which cleaning process is suitable for either dry cleaning or laundry washing. Dry cleaning involves the usage of a chemical like perchloroethyl for removing stains, while laundry washing comprises traditional machine washing with detergents, softener, and water. The following table gives the comparison between natural and synthetic fibers. Plastic. Plastic is also a synthetic material which can be easily molded into any desired shape on heating. Plastic is also a polymer like the synthetic fibers. In some plastics, the arrangement of monomers is linear, whereas in others it is cross-linked as shown on the screen. Plastic can be recycled, colored, reused, molded, or drawn into wires. Owing to this reason, plastic is used in making toys, suitcases, bags, brushes, cabinets, chairs, tables, and many other countless items. We also must be familiar with many plastic articles used every day, like milk and oil pouches, containers to store pickles, buckets to store water, water pipes, electric appliances like television and radio. Everything seems to be made of plastic. To a great extent, plastic has taken over the place that was occupied by metals, glass, cloth, paper, stone, and wood earlier. Plastics have completely occupied our life because of their characteristic properties. Plastics can be classified into following categories based on their thermal properties. They are thermoplastics, thermosetting plastics. Click each tab to know more. Plastics which change their shape on heating and can be bent easily are called thermoplastics. Polythene, PVC, and polystyrene are common examples of thermoplastics. Plastics which do not soften much on heating and can be molded only once is called thermosetting plastic. Bakelite and melamine are common examples of thermosetting plastics. Here, we perform a lab activity for identification of thermoplastic and thermosetting plastic. Click each tab to know more. The aim of this activity is to identify the thermoplastic and thermosetting plastics by flame test. The materials used in this lab activity are pair of tongs, spirit lamp, samples of plastics. Collect small pieces of plastics from the objects like comb, toothbrush handle, plastic bucket, handle of utensil, electric switch, piece of melamine of meals plate, and coffee mug. Precaution: while performing this activity, you should cover your nose and mouth with a mask to avoid breathing of fumes, and also keep away from spirit lamp flame while placing the sample of plastic on the flame by stretching your hand. Take a spirit lamp and light it. Hold one piece of plastic sample, say piece of comb, with a pair of tongs. Now, place the sample piece on the spirit lamp flame. Observe the changes during the burning of sample comb. Record the observations, like whether the sample is being softened or burnt with smell and becomes hard. Repeat the same procedure with other sample pieces of plastics. The observations are shown on the screen as a table. Finally, we have learned that the thermoplastic and thermosettings plastics can be identified by the flame test. Now, we will study the uses of thermoplastics. A thermoplastic is a polymer in which monomers are arranged in a straight chain that turns into a liquid when heated and freeze to a glassy state when cooled sufficiently. Thermoplastics are used in making toys, bottles, combs, containers, etc. Polythene is one of the most famous types of plastic, which is used in manufacturing carry bags and for wrapping food and other eatables. PVC is used as an insulating covering for electrical wiring and also used for making shoes and shoe soles. Polystyrene is used as packing material for expensive items such as TVs, refrigerators, cell phones, and other delicate objects. Now, we will study the uses of thermosetting plastics. Thermosetting plastics are used in making electric switch, handles of electrical appliances, handles of kitchen utensils, floor tiles, etc. These thermosetting plastics are not moldable because strong cross-links are formed during the initial molding process, which give the material a stable structure. For this reason, they are more likely to be used in the situations where thermal stability is required. Bakelite is a poor conductor of heat and electricity and is therefore used in making electrical switches, handles of various utensils, and telephone cases. Bakelite is also used as an alternative for pearl and jade. Melamine is a versatile material, resists fire, and can tolerate heat better than other plastics. So, it is used for making kitchenware, floor tiles, and fabrics which resist fire like computer and TV cabinets. The following table gives the difference between thermoplastic and thermosetting plastic. Plastics and environment. Plastics have so many desirable properties that they have proved to be extremely versatile materials with a number of uses. However, some of the properties such as long life, toughness, resistance to chemicals and biological agents that make them so useful cause problems when the goods are past their useful life. When plastic objects like polythene bags are thrown away, they do not degrade either chemically or biologically. As a result, plastic junk is increasing at an alarming rate, which causes certain environmental hazards, and this is becoming a global concern. Let us study the biodegradable and non-biodegradable materials. When we go to the market, we get usually things wrapped in plastic or packed in polythene bags every time. That is one reason why plastic waste keeps getting accumulated in our homes. Ultimately, plastic finds its way to the garbage. We know that decomposition is a process that can break down certain materials into smaller fragments in the presence of water, sunlight, and oxygen, and these fragments further break down into bacteria. A material which is easily decomposed by natural process is called biodegradable, and one which is not decomposed by natural processes is called non-biodegradable. The table which is shown on screen is used to know the time required for the various sources of materials to decompose. The time taken for decomposition depends upon whether a material is biodegradable or not. Now, we will discuss the effects of excessive plastic on environment. Plastic bags like polythene cover contains leftover food material eaten by animals in urban areas, particularly cows, results in their death. Plastic bags choke the drains, which results in the overflowing of wastewater and become good reproduction place for mosquitoes. The burning process of plastic releases a lot of poisonous fumes into air, causing air pollution. This burning process is also very slow and cannot be burned completely. Plastic takes several years of time to decompose, so it reduces the percolation of water into the soil and prevents replenishment of groundwater. Plastic materials, when thrown out, destroy the natural beauty of a place and provide homes for many pathogens. Now, let us read the comments of Supreme Court of India about effects of plastic and environment. Supreme Court of India: plastic bags are more danger than atom bomb for future generations. Excessive use of plastic bags and their unregulated disposal has been choking lakes, ponds and urban sewerage systems, the Supreme Court said while warning that it posed a threat more serious than the atom bomb for the next generation. Andhra Pradesh-based NGOs drew the court's attention to 30 to 60 kg of plastic bags recovered from the stomachs of cows because of irresponsible disposal of plastic bags and defunct municipal waste collection system. But the bench wanted to address the larger questions arising from the indiscriminate use of plastic bags, which not only posed a grave threat to nature and environment, but also to the human race itself. All of us are watching how our lakes, ponds and urban sewerage systems are getting choked by plastic bags. Unless we place a total ban on plastic bags or put in place a system for manufacturers mandating them to collect back all plastic bags, the next generation will be threatened by something more serious than the atom bomb, Justices Singhvi and Mukhopadhyaya said. Large quantities of water packed in plastic pouches are thrown around in an undisciplined and uncivil manner across the country every day. A rough estimate shows that more than 100 million water pouches are thrown all over the cities and towns in a day, the bench said. The petitioner sought the following directions from the court: prohibit or phase out in a time-bound manner open garbage disposal system and remove open garbage receptacles. Implement door-to-door garbage collection and prevent animals from moving around garbage storage facilities. Municipalities must segregate all plastic waste from other waste. States must issue directions prohibiting the use, sale and disposal of plastic bags in all municipal areas. Provide animal shelters and treat cows and other animals suffering from stomachache due to ingestion of plastic. There are 4 possible ways to overcome the problem of waste accumulation of plastic. They are reduce, reuse, recycle and recover. Click each tab to know more. Reduce. We should reduce the use of plastic whenever it is possible. For example, instead of using plastic bags, we can use cloth or jute bags for shopping. Reuse. We should reuse some plastic containers whenever it is possible. For example, empty bottles and jars can be used for keeping other items in the home and kitchen. Recycle. We should collect plastics which can be recycled. Most of the thermoplastics can be recycled. So items made of thermoplastic should be sent to the recycling industry. For example, toys, buckets, mugs, etc. are made from thermoplastic. Recover. The principle of recovery plays a major role in this solid waste management. The recollected or recovered solid waste should be converted into resources such as electricity, heat, compost, and fuel through thermal and biological means. Note: Supreme Court gave a judgment on ways and means of solid waste management and gave an order to implement this in all the cities of India by 2003. Now, we can discuss about the recycling codes. In 1988, the American Society of Plastics Industry developed a standard marking code to help consumers identify and sort the main types of plastic. There are 60,000 types of plastics available in the world as on today, but only 6 types of plastics that we use regularly. These plastics are sorted according to their resin identification code. These codes are in a triangle-shaped symbol with a number in its center. The symbol is known as the universal recycling symbol, indicating generic recyclable materials. To identify the plastic, look at the recycling icon. The chasing arrows, inside the arrows there will be a number that indicates the type of resin and also identifies the polymer. There are 6 different types of plastic resins that are commonly used to package household products. The identification codes are shown on the screen, and these codes can be found on the bottom of most plastic packaging. Here, the category of other includes any resin not specifically numbered 1, 2, 3, 4, 5 or 6 or combinations of one or more of these resins. PET code 1 and HDPE code 2 are commonly recycled, whereas PVC code 3, which is used for pipes, is currently not recycled. Likewise, LDPE code 4, which is used for carrier bags, is commonly not recycled. The PP code 5, which is used for making DVD cases, food containers, can be recycled. Similarly, the PS code 6, used for making coffee cups, egg boxes, packing peanuts, and take-out food packing, can be recycled. Recycling can be used to obtain materials from which the original products were made. Here, let us study the role of codes in recycling process. We know that each plastic is manufactured with different processes. During recycling process, if the same codes are not sorted out separately, the whole lot meant for recycling will spoil the process. That is why it is necessary to recycle the same codes in one lot. For example, if we add a simple PET bottle in the lot of other plastics during the recycling process, the entire lot will be spoiled. To understand this, we need to study the uncoded plastics. Now, we can discuss what are uncoded plastics. Plastic tarps, pipes, toys, computer keyboards, and a multitude of other products simply do not fit into the coding system that identifies plastics used in consumer containers for recycling. There are actually thousands of different varieties of plastic resins or mixtures of resins. These are developed to suit the needs of particular products. But there is a limited recycling of some of these specific plastic products in truckload quantities from industrial sources. Recycling of various types of plastics is not commercially viable because their production when compared to coated plastics is less. Code 1 and Code 2 plastics occupy a major share in recycled plastics.
Read the questions and attempt the answers on your own. You can click Answer for your reference.
Follow-up work. Design a poster on the topic, say No to Plastic, to discourage people from using plastic bags. Find out the rayon manufactured in our state by searching in internet. Find out government and non-government organizations in your area which are carrying out awareness programs on the indiscriminate use of plastic, which is a serious threat to biodiversity. You have successfully completed the chapter Synthetic Fibers and Plastics.